Good evening, everyone. I hope everyone is doing well. Yeah, good evening. Yes, so welcome back to our 30 days free short term training from Python to AI, friends. What did we discuss in the last class? In the last class, we have understood one of these steps under data pre-processing. Okay, so actually we started with data pre-processing or data cleansing. Nothing but we are cleaning the data, right? So as part of this data pre-processing or data cleaning or data merging or data wrangling, whatever it might be, there are in total 9 steps. So we discussed the typecasting, the first step. What is typecasting? Typecasting is nothing but conversion of data type from one to the other. Then the second one is handling duplicates. So if we have duplicates in our data, we are supposed to identify them and remove it. Okay, whatever the duplicates that we have in the data, we have to remove such kind of duplicates from the data. What is the function that was used with respect to typecasting, friends? What function was used in order to do type conversion? What function did we use? It is as type. As type is a function used for good for typecasting. Okay, then handling duplicates. What functions did we use in order to handle duplicates? We use two functions. One is duplicated. This function will actually identify duplicates. Only it identifies the duplicates. But there is one more function, drop underscore duplicates. This function will drop the duplicates, will remove the duplicates. Good. Duplicated will identify, drop underscore duplicates will identify and drop. I mean, especially they are used to drop the duplicates. What is a parameter, important parameter that we have discussed under duplicating function? It is keep parameter. And this keep parameter by default takes first as the value. What if you don't, if you want to use any other value instead of first, you can also give last. If not, there is one more value, that is false. First will actually mark or drop the first, it marks false only for the first occurrence, and rest of the occurrences will be marked as true. Last, the last occurrence will be marked as true, and rest of the occurrences will be marked as false. Whereas false, all the occurrences will be marked as true. So either we use first or last, that's it. But just to be cautious, we are learning each and every value for key parameter. Done. Then we understood the third step. What is the third step? The third step is outlier treatment. Okay, what is an outlier? Outliers are nothing but the extreme values. Okay, the extreme values in the data are nothing but outliers. If we have outliers in the data set, in our data, they may affect the model negatively. So what are we doing? We are treating these outliers. Okay, first of all, how to know whether we have outliers or not? Are we? Is there any existence or presence of outliers in the data? How can we check that? Box plot. When we visualize box plot, we can confidently tell that either we have outliers or not in the data. Okay, so lower limit, upper limit. And if a value present in that particular column, if it is less than lower limit, or if a value greater than upper limit, you know, these kind of values will be extreme and they are nothing but outliers. Okay, so these are nothing but outliers. We are supposed to treat these outliers. So initially we'll visualize box plot and we'll check in how many columns are, which columns has outliers, extreme values present in the data set, and we are supposed to treat it. What are the different techniques that we have understood? The first technique that we have understood is RRR, not Rajamouli's movie. It is recognize, remove, and retain. Okay, or replace, whatever it might be. So recognize is where we just recognize that, you know, we are identifying the outliers, right? How many outliers are present? Okay, so we are just recognizing them. That's it, using recognize method. But in order to use this 3R technique, any one of the R, we have to calculate the components of box plot. What are the components of box plot? Q1, Q2, Q3, IQR, then lower limit, upper limit. Why, Akhil? What is the necessary of calculating these components? Because when we write the logic, in order to define our logic, ultimately, we need lower limit and upper limit. Based on the values of lower limit and upper limit only, we are defining the logic. So, in order to know the lower limit and upper limit of the box plot, we have to know Q1, Q2, Q3, and IQR, especially Q1 and Q3 and IQR, right? So, component should be calculated manually for each and every column. Then it's up to you. Either you want to recognize, just identify only the outliers, or remove the outliers, or replace the outliers. Recognize, is it handling the outliers? No, it is just telling the count how many outliers are present in the data. But remove, what it is doing, it is removing the outliers from the data. This is actually creating data loss. In real world, this remove technique is not generally preferred. This is the last preferable option in real world because you'll have that data loss that is not accepted in real world, right? So remove is actually removing the outliers from the data set, and the final one is replace, where we replace the outliers with the lower limit or upper limit value. Okay, if a value is less than lower limit, if this is the outlier, so this particular outlier will be replaced with lower limit, right? Then this particular value will be replaced with upper limit. In such case, you'll not find outliers anymore. That is what replace technique talks about. Okay, then it's bit tough to define the logic. Even it's bit lengthy to as a process. If you observe properly, you have to calculate all the components, then define the logic. So this will be the action of plan. So instead of doing all these things, we have a widely used technique called Vincerization. A widely used technique called Vincerization to treat outliers. Okay, Vincerization also performs a kind of rectify retain technique only, but we need not calculate all these components. Then what should I do with respect to Vincerization? You have to import that particular function. What is the function? Vincerizer. Okay, this Vincerizer function is present in which module? It is present in a module called feature underscore engine. How many of you have tried importing feature underscore engine? Did you guys try importing feature underscore engine? Come on, friends. Did you do that on any data set? Hmm. Did you try working on, using winsorization? Anyone? Okay. So what happens is this feature underscore engine, in general, you may not observe inside your, you may not have it in your local machine. So what you have to do is you have to install it. What will be the command? The command will be pip install module name. So feature underscore engine, uh, you will import initially. Then from feature underscore engine dot outlier sub package sub module, there is a function like called as winsorizer. Okay, so you will be importing only winsorizer. Once after importing this winsorizer, we'll initialize the winsorizer. What do you mean by initializing? That means whatever the values that you want to pass to the parameters, you will declare all the parameter values and initialize that function. And this particular initialization will be assigned to a variable, and that particular variable will be considered as function. Okay, so taking that particular object as function, you will perform fit underscore transform on data. That means this particular object gets fitted on the data and it also transforms the results. The results get transformed into the same, data frame or whatever might be the object. Once this is done, you will again, in order to cross check, we again visualize a box plot and we'll check whether we have outliers or not. If you don't observe any kind of outliers, if the outliers got treated, then we can, tell that probably this particular values for the parameters are actually doing well. If not, again, you'll try to pass new values for the parameters inside the winterizer function. That will be the action of scope. So on Saturday, I mean in the last class, majority of the folks haven't joined, but I request all of you to go through this particular video. Okay, I want you guys to go through this session, because this is a very important step with respect to data cleaning. Okay, so on Saturday we just come. Oh, see here. It took 1 hour, almost 1 hour 20 minutes or 1 hour 30 minutes to talk about or to explain only outlier treatment. It's a big step. Okay, understanding each and every part of 3R technique, then Winsorizer. It took lot of time for us. So I did not extend the session. I just stopped it by just completing this outlier treatment. So people who did not attend this particular session, I want everyone to go through this session post after completing today's session, right? So if you have any kind of technical questions, we'll discuss at the last. For now, we'll just proceed. We are done with total 3 steps. The fourth step is zero and near zero variance. Okay, let me remove all of this. The fourth one that we have is zero and near zero variance. Oh, Akhil, I think I am aware of variance. Yes, friends. We already discussed what is variance. What is variance? Come on, friends. What is variance? Second moment business decision. Did we discuss? Yes or no? Average spread from the center. Good. It is represented with sigma square. Summation of x minus mu whole square divided by n. Okay, so this is nothing but variance. But what is the disadvantage of considering variance? We get squared values, we get squared spread, and in order to get the original spread, we consider standard deviation, which is nothing but square root of variance. Okay, this is something we are clear about these topics. But what is this topic called as? What is this step called as? Zero and near zero variance. What is the meaning for that? It says if your variance is zero or or if your variance, if it is close to zero, if your variance is zero, or if the variance for a particular data is close to zero, then what I have to do for such kind of data? What should I do on such kind of data? Such kind of columns or such kind of variables should be removed or dropped. Why? Why should I drop such kind of variables, such kind of columns? Is the question. Why should I do that? Tell me, friends. Just go for a wild guess. Why should I remove or why should I drop such kind of variables? Think, then comment. Use chat, respond. Just give a try. Even though if you're wrong, see. But sitting idle doesn't make sense, right? Hmm. Just give a try. If spread is zero, we can't find any use for analysis of data. Good. All such variables may give some same prediction. Not exactly. There is no spread. That's what. The question is, if there is no spread in the data, okay, why are we dropping them? Is the question. I'll just give an example, friends. How many of you watch cricket? Do you watch cricket? Uh, is it duplication or I'm not actually clear about it. Avoid duplication. No, we are not reducing any kind of time, but I'll tell you the actual reason. Come on, friends. Do you watch cricket? Yes or no? Yes or no? Oh my God. Yes. So, who is your favorite player? What is the majority of you say yes? Good. Who is your favorite player? Sachin Tendulkar. Okay. Good response. Nitish Kumar Reddy says one. Okay, Jaiswal. Okay, I'm getting weird answers. That's fine. But to be frank, what is the ongoing MS Dhoni? Okay, hmm? And what is the ongoing Sachin? Yeah. So what is the ongoing tournament that is being you know held from past 1 month? India is playing with Australia, right? What is the trophy called? Border Gavaskar Trophy. Good. And I'm a great fan of Sachin and even Rohit as well. But why am I telling you the example is, if you take border Gavaskar trophy, border Gavaskar trophy is what being held from past 1 month, right? So today, unfortunately, we lost the fourth test as well. So if you see the stats, okay, so what is the performance of Rohit and Virat Kohli? Are they performing well? What is your take? Yes or no? Yeah, Australia won the match. That's good. Are they performing well? No. No, they are not performing well. Now, yeah, obviously, there are a lot of, you know, uh, what lot of news being held with respect to Rohit and Virat performance. But the thing is, let us not consider this trophy. I'll go back an year or probably 2 years back. Now, I'll ask you, just compare only Rohit and Virat performance. Who is the consistent player who performs consistently? Do Virat or Rohit play consistently? Who is the player who, you know, whose performance is consistent? It's Virat. Assume that I took, stats of say around 2019 or even 2021 or 2022. In general, Virat's performance will be consistent. Okay, might be in an ODI. I'm taking off say 10 matches. On an average, he's scoring around say 80, okay, 75, 95, okay, then 60, then 85, like this, consistently. Right? Now let me come to Rohit. Rohit, what about his performance? Might be first match he will go for a duck, but in second match he'll score 200. Third match, probably 40. Fourth match around 100. Okay, and fifth match might be around you know uh, 20. Am I right? Yeah, it will be up and down. Yes. I'm trying to explain zero and near zero variance trends. Focus. If I observe the stats of Rohit and Virat Kohli, Virat plays consistently, right? So when I try to understand the stats of Virat, I don't see much variation. There is no spread in the data. I'll calculate the average of all these matches and I'll try to get the spread. Okay, spread is say assume here I have spread assume, but what if he is scoring 80 in all the matches? Obviously, the spread will be zero. There is no spread. But if you take Rohit stats, there will be some spread. Some X value will be there. Okay, you'll not see normally distributed curve, but either you'll see a right skewed or left skewed curve with respect to Rohit stats. What can I interpret from this? I can see that Virat is performing consistently across all the matches, and Rohit's performance is not consistent. But when I try to do analysis, mark the word, when I try to do analysis, I can get more information from Rohit's stats. Why? There is spread. If the data has spread in it, we can understand or interpret more from it instead of the data in which there is no spread. Okay, and these this such kind of columns, such kind of variables may affect some models negatively also. Okay, what is the next step to what is the next phase of CRISP MLQ after data preparation? It's nothing but model building. Okay, so by using the variables, by using the columns, I have to build a model. Y is equals to f of x. A model has to be created, and whatever the columns or the features are that you are using to build this model, and if this model contains such kind of columns, zero and near zero variance columns, your model results will be biased. Your model results get affected. So that is the reason upfront, before building itself, in the second phase, as part of CRISP MLQ, we are identifying such kind of columns and we are dropping them. Okay, so again the question is, Akhil, if it is zero, perfect, we'll remove it. Okay, because zero is zero for everyone, but you are also telling it as near zero variance, right? Near zero means what is that value? Is it 0.1 or 1.0 or 10.0? What is that value near to zero? The question comes here. Am I right? Yes. The reason is 0.1 is also close to 0, 1.0 is also close to 0, but compared to these both, 0.1 is close to 0. So here comes subject matter experts. In real world, we have subject matter experts or domain experts for each and every project that we do. What are these? Who are these folks? Subject matter experts means you are doing a project, right? So that project will be related to a particular domain. So in this particular domain, okay, there will be an expert. Whatever the project that you're working on, it will be related to a domain. So on that particular domain, we have an expert. So he or she will be named as domain expert or subject matter expert. And in such cases, we have to include these folks, especially in these cases, we have to include these people, and we'll take a call whether we have to drop a column, whether we have to consider the column or not. Right? So the process is similar, guys. We'll calculate variance for all the columns. In order to calculate variance, the function is var. So we'll calculate the variance. If you observe zero, okay, you can directly, ignore it, drop it. But what if it is near to zero? Then include them. Right? This will be the process. For time being, we'll proceed as we don't have any subject matter expert or domain expert, since we are not working on any project now, right? So we'll be the subject matter experts ourselves. Right. I'll proceed with the code. Okay. I'm importing pandas. Okay, because pandas is a module which is used for data manipulation. Then I'm reading the same data set, friends, cars Excel sheet that we have used for typecasting, then duplicates, outlier analysis. For all these things, we use this the same data set. So let me use the same data set as well. Now let me get the data types. Further, I'm printing data types of each column. So that got printed to the console. Then D types. Data frame dot D types will return us the data types of each and every column. So you see these are the data types. It's not a new data set. I need not explain one more time. Okay, we have understood clearly about each and every column with respect to typecasting topic. Now I'll go and calculate the variance. What is a syntax? Akhil, I remember we calculated variance for one column. How? What is the syntax? Syntax is, data frame object, whatever the data frame object that is, df dot, then the column msrp is a column dot, variance var function. So this will calculate variance for only one column, that is MSRP, manufacturer suggested retail price. But Am I going to calculate variance only for one column? No, for the entire data frame. For the entire data frame, I'm calculating the variance. So I did not specify any column. I removed this so that it calculates the variance for all the columns at a time. Let's see. Okay, now I'm executing. Done. Where did I store the values? Did I store it to the did I print it to the console? No, I have stored it to a variable, and the variable object is nothing but variance. So what did we get? We got a series, and in the series there are only 9 rows. See friends, why did we get only 9 rows? There are in total 14, right? There are 14 columns, but I see only, variance values for 9 columns. What is the reason for it? I am working on a data set which contains 14 columns, but out of 14, only 9 of them are numeric. Good. Variance, friends, you have to be very careful. Okay, what did we discuss with respect to EDA? In EDA, the only measure that can be calculated for non-numeric column is mode. Apart from mode, any other measure can be calculated for non-numeric data? No. So that is the answer. Variance will be calculated only for numeric columns. Out of 14, 9 of them are numeric. So here are the values. Now tell me, do you find any of the value, any of the variance value 0 as 0? Good, good. Any of these variance values are 0? No. None of the column has the variance as the value 0. Don't assume this is 0, friends. This is nothing but 3.7 into E is there, right? E is nothing but 10. 10 to the power 8. So obviously you'll get a very big number. Okay, when you try to sort it, obviously you'll see the value in the last position because this is very big number. 3.7 into 10 power 8. Right? So I don't see any column of my data set which has variance value as 0. What am I doing? I'm printing these values to the console using print function. So these are the values. See. Clear? Then what am I doing? I'm also cross checking, like, what is this operator called? What operator it is? What operator it is? Comparison operator, right? Under comparison operator also, what kind of operator it is? What is the name of the operator? Equals to, equality. Good. So comparison operator will return either true or false, right? So what will be the output for this line of code? Is equals to, good. What will be the output for this line of code? Obviously false. You should get only false, friend. For all you are checking that df dot variance, nothing but for each and every column, numeric column, when you calculate variance, you are checking whether the value is 0 or not. If it is 0, you get true. If not, you should get false. Clear? We are just comparing. Okay, so this is actually telling that there is no column where we have the values as 0. The variance values as 0. So can I proceed? Yes, I can proceed as is because I did not find any kind of. But still, if you observe, I see the variance value as 1.2 in for engine science column. So here might be I can include a domain or subject matter expert. So by taking the help of a subject matter expert. So what is this domain? This is something related to manufacturing, industries, right? So manufacturing domain. So a person who is good at manufacturing and all automobiles, so I have to include him or her, and I take a decision whether should I consider engine size or not. Obviously, they'll say yes. So I'll proceed taking engine size column. Good. So this is what zero and near zero variance talk about. I hope it's clear. It's a very small topic. Okay. Now comes the actual topic. The next step, discretization. Okay. What is this discretization, binning, or grouping called as? So these are different names given for discretization. What is grouping? What is binning? Then we should I mean, you see, if you get true for any one of the column, then you have to drop it off, remove that particular column from the data, because the variance is zero, or if it is zero, yes, obviously you have to take a call in the sense you have to remove it. Even before, in real world, whatever you are going to do, you have to, before you do, you have to approach subject matter experts, because you are dropping a column, a feature. You don't know whether see, as we have discussed, AI or data science, machine learning, they are not restricted to one domain, and we cannot be proficient in each and every domains, right? So assume that I come from civil background, or assume I come from electronics background. Okay, what do I know about manufacturing? This is something related to automobiles manufacturing. I don't know anything about this domain, but I'm technically sound with the concepts of data science, AI. I'm good at Python. So I'll approach the subject matter experts, domain experts. By taking the help of the domain experts, I'll take a call whether I have to drop or not. Right. So the next step is binning, grouping. Binning is nothing but you are actually grouping them. So combining. In the same way, discretization is also nothing but a process of binning. But what is this discretization exactly? Discretization means the process of converting continuous data to discrete data. If you have continuous data, and if you want to convert this continuous data to discrete data, then perform discretization. Oh, then it's again something important. In the back end, if you observe, what does histogram do? Histogram is doing this binning concept only, my friend. It is actually binning the data, bins, bin by bin. So what's happening? It is grouping the data into a particular bin, right? So if you want to convert this continuous data to discrete data, then we have to perform discretization. Okay, and that function that we use here is cut. I'll talk about this function as we move on. Okay, how this cut function works and all we'll discuss. Right. So let us jump into the hands-on, because there is nothing much to discuss with respect to the concept under this topic. So we'll take a use case taking the same data set. Okay. So I'm taking the same what? Cars data set, then storing it in data. So this is my data. Then I'm performing discretization. First of all, I'm performing binarization on engine size. First of all, let me go and check what kind of data is engine size. Engine size is a continuous data. Am I right? Yes. It is having kind of decimal value. So obviously it will be continuous data. And this continuous data, I want to convert it into discrete data. So what I'll be doing, I'll be using discretization concept. Under discretization, we have a subtopic called as binarization. What is this binarization means? Binarization means, converting your data into two bins. Okay, if you want to convert your data into two bins, then it is called as binarization. Now let us understand this part. First of all, we'll understand this part. Then we can go to this left hand side part of equals to. As we discussed, in discretization, we use cut function. Cut function comes from pandas. PD dot cut. Okay, so cut function, inside the function, I am defining the parameters and the values. Okay, what is the column that we are using? I want to perform the discretization, binarization on engine size column. So data of engine size. This is nothing but data dot engine size. Both are same. But I told you the difference, right? What makes the difference between data dot engine size and data of engine size? Both are representing engine size column only from data frame. Okay, but when do we generally use this kind of syntax is when we want to use only once the engine size column in the entire line of code. If you want to use only once the column, then this is preferred. But here, how many times am I using? I'm using here. I'm also using in different places. So again, it's up to you. If you want to use data dot engine size, that is also accepted. Okay, so this is the data. Then the second parameter that I'm using is bins, and I'm defining the bins. Okay, so the bins I'm defining in a list, right? Min of data dot engine size. What does this written? The minimum value of this column. Then data dot engine size dot mean. This will return average of this particular column. Okay, then max of data dot engine size. This will return maximum value present in engine size. So tell me how many bins is it going to create? When I keep all these values, how many bins will I get? Will I get 2 or 3 or 4? Will I get 3? Sure? Come on, friends. Okay. How many? How many bins? Not link. How many bins? What will be the bin count? The bin count will not be 3. 2. Good. No, no, not 3 bins, friends. Only 2 bins. Why? What is a bin? In histogram, what is a bin? This is a histogram. This is the bin. This is the bin. This is a bin. So, what do you mean to say, Akhil? I mean to say that a bin will have a starting value, ending value, a starting value, ending value, starting value, ending value. So, if I am specifying 3 values, that means I'll get 2 bins only. Don't get confused. Okay, so this will be minimum value from, it will start at minimum value and it will stop. The first bin will take till average of that particular column. Then again it starts from average, it goes till max. This is just an example, friends. Okay. So this will be one, this will be second. So only two bins, it will not be three. That is the reason it is called as binarization. Binarization means, because it is a part of discretization where we convert this continuous data into two discrete values by two, into two bins. Okay, then I am specifying the labels for the bins. The first label should take low and the second label should take high. I hope it's clear. The first label should take low, the second table should take high. So it's very clear, and these values, whatever I get low, high, all of them will sit in a new column under the same data frame. I am creating a new column called engine size underscore new, and under this column I have low, high depending upon the value. Okay, if the value falls under first bin, it takes low. If the value falls under second bin, it takes high. Clear? Yes. Now let's execute. If you have any kind of questions with respect to the code, ask it immediately, friends. Technical questions we can deal later, but coding and all we have to, cover it off at the same moment. I have executed. Now let me open the same data frame. Previously the size is 14, now it became 15. See. So in the last column will be the new column. Engine size underscore new is the column. Okay, so let me do it. I mean, I'm sorting the data from in ascending order. You see here, I'm getting two null values, NaN values, but rest of the values, yes, I see low, properly low is what I observe. Good. Then from where it is high, it's around 3.2. So might be 3.2 is uh, the average. It is high till the last value. But the question that we come here is, the question that we generally have it here is, why did we get null values for the new column? This is a new column, right? Engine size underscore new. Why did I get null values? Did I do anything wrong? No, everything is perfect. It executed for me also. Okay, better I'll go and check the count of each and every discrete value. For that, what I'm doing, I'm going to use a function called value underscore counts. This is very important function. Why, I'll tell you. But before that, I'm printing a string count of cars in each low and high category. So under each category, what is the count of cars is what I'm going to check. So it got printed. Then in order to get the count of cars in each and every category, what am I doing? I'm going to use the same syntax, data frame dot engine size underscore new, the new column that was created just now, dot value counts. What is this value counts? We are using for the first time, right? Value counts is a function which returns the unique values present in this particular column and also the count of each and every unique value. First of all, what are the unique values that we have in engine size underscore new? I'll have only two values, those are low and high. So initially it returns low and high, then count of low and count of high. That is what value underscore counts function returns. See. 219, 207. So obviously majority of the cars are falling under the lower bin. Okay. Now let us add these both of these two values. 200 plus 200 is 400. 19 plus 7 is 26. So 426 is what I got. But how many rows I have? 428. Why this happened? What is the reason for it? Two rows are missing. That means two cars are not assigned to low or high. So because of that, there is a mismatch with respect to the number of rows and the values that we got with respect to low and high count. So I understood that there is a parameter inside cut function called as include underscore lowest. Okay, there is a parameter called include underscore lowest inside cut function, which is not defined previously. Did I use include underscore lowest in the previous code, line of code? No. But now I take the same code, I include it. So by default, it takes false. What does this mean? This is actually, it is telling that the minimum value, the lowest value that we have in the data will not be included in general. Include underscore lowest takes false by default. Actually, how come you know that point? Because I have gone through the documentation of cut function. I have gone through the documentation of cut function and I am aware of it. So in the same way, you should also go through the documentations. As I have suggested, you should go through the documentation of these functions. Okay, so include underscore lowest will be by default taking false and making it as true, and now the lowest value present in the data will be included. Okay, and these values will be storing in the new column engine size underscore new one. This is also done. Let me open it. Let me sort the data. Now I see the values. But previously it is null. Why? It is not including. Understood? Right? Any questions? So, I can clearly see that. Once again, I'll repeat. See, what I'm trying to say is here. Let me open this data frame. So, in this data frame itself, I'm trying to convert this continuous data into discrete. Okay, but instead of going with multiple bins, what am I doing here? I'm converting this discrete continuous data into two bins only. That is called as binarization. One bin is named as low and one bin is named as high. Okay, so in the experiment one, I did not include the parameter called include underscore lowest. What does that mean? Include underscore lowest is actually telling whether to include the lowest value. What is the lowest value in this column? 1.3. 1.3 is the lowest value in this column. So by default, include underscore lowest takes false. That means don't include the lowest value in the binarization process or whatever it might be. So since I did not define it as true, I did not specify include underscore lowest is equals to true. It did not include and it given a none value. But in the later code, later steps of code, what did I do? I have included lowest underscore include underscore lowest, that I kept it as true, so it included and it is part of bin low. That's what, my friend. See, don't get confused. Hmm. See, this line, 1 minute. This column that you see here, uh, right. So this column that you see here, engine size underscore new, was created using these lines of code from line number 251 till 255. So in these lines of code, did I use include underscore lowest? This parameter was included here? No. Here it will be taken as include underscore will be false. The lowest value in this particular column, okay, should not be included. That's what it is telling. It did not include, so it returned a null value. Whereas in the next lines of code, from line number 263 till 268, I have kept or I have changed the value for include underscore lowest from false to true. And where am I storing the values? I am storing the values in engine size underscore new, a new column. Okay, so into this new column, the values will be same. Okay, since I have changed this value for the parameter, it is including, but here it did not include. That is the difference. Is it clear now? I hope it's clear now, right? Yes or no? Yes. Now I'm doing the same process. I'm just printing the string as is. Then I'm also getting the values underscore counts done for the new column. So it says 221 under low and 207 under high. So if you add both of these values, you'll get 428. 221 plus 207. 400 plus 28. 428. Is it clear? Yes. So binarization is what we have understood. Okay. Now let us go with the discretization. No, friends, don't get confused. Hmm. See, this will just return the minimum value of that particular column. This is what I am talking about. This particular parameter, which is available inside cut function, by default, it will take false. Read documentation after the session. Read the documentation. It will take false by default. So that is the reason, the lowest values in this column, engine size, will not be included. Okay, but here I'm changing that value from false to true so that the minimum value will also be included. That is the difference. There is nothing else. Okay, right. So discretization is what binarization we understood, but what is discretization? Discretization is nothing that. So when you try to you know convert this continuous data into discrete data, but into multiple bins. Okay, so that is called as discretization. More than two bins, if you are going to convert it, then it is called as discretization. The same process. Now you tell me how many bins are going to be created from line number 275 till 282. How many bins are you going to get? Just go through the code and tell me how many bins will we get. Four? Sure? Yes, four. How come? This will be the first, from minimum till 25th percentile, this will calculate 25th percentile. If you remember q1, this will be the first bin. Then from q1 till q2, the median, but here I'm just going with the mean. Okay, so in box plot it is median. Okay, but in general I'm assuming the mean as the average. Okay, so from q1 till mean it will be second bin. Then from average till q3 it will be third bin. Then from q3 till the maximum value it will be fourth bin. In total we have to get 4 bins. Okay, and 4 bins are taking these labels: small, medium, large, extra large. And I have also specified true as, I mean, include underscore lowest as true. So that means the lowest value will also be included. Now I'm executing, a new column will be created again. So let me show you. This is the new column. See, bin 3, bin 4, then bin 2, bin 1, everything we have. See, a continuous data was converted to discrete data. This is nothing but discretization. Okay, and I can also get the count of each and every bin using value underscore counts. So even if you add up all these values, you should get number of rows. You should get 428. 400, 14 plus 7, 21 plus 4, 25 plus 3, 28. 400 plus 28, 428. Clear? Is it clear? In total, we get 4 bins, and that is the count. Right. So this is what discretization is talking about. Okay. So discretization is nothing but the process of converting continuous data into discrete data. Right. Done. The next step is nothing but dummy variables or feature encoding. Okay, the next step that we have under data pre-processing is dummy variables or feature encoding. What is this dummy variable? Variable is nothing but a column. That's clear. So dummy variable, dummy column is what I want to create. Feature encoding, feature is nothing but column and you are encoding the column. Why are we encoding or why are we creating dummy columns is what we'll understand. Right. Here comes a small example for it. Let us understand this step. Dummy columns. What is this dummy column creation or feature encoding? Right. So there is a data set, friends. Okay. In a data set, one of the column is like this. Gender is my column. Male, female, male, female, female, male. Then again male. So this is how the data is with respect to this column. And the question is, and why am I speaking about this particular column is, I'll talk about a particular use case. Assume this data that I am actually working on is related to cancer prediction. I repeat, I'm working on a data set, okay, in order to build a model for cancer prediction. So what did I do is, I gathered the data, okay, I got the data from a hospital, and this hospital, they are generally very good at treating the people, diagnosing the cancer. So with respect to the cancer, they are actually undergoing a study case, the use case, and as purpose of it, they have recorded the patient details. So in that way, they got the gender of the patient, and either the patient has cancer or not is what they have recorded the data. Perfect. But out of all these columns, one of the column is gender. Okay. Why am I specifically talking about gender? You'll understand. Now comes the question. So what are we going to predict? I'm going to predict whether a person will have cancer or not using ML, machine learning. I'm going to build a model, and that model is nothing but y is equals to f of x, and this model will predict either the person has cancer or no cancer. But when it will predict, when you pass all the inputs, the required inputs, it will predict whether the person has cancer or no cancer. Right. So the question is, one of the input is gender. One of the column that we have is gender. But this is nothing but f of x represents a mathematical equation, right? F of x is nothing but a mathematical equation, ax1 plus bx2 plus cx3, so on. x1, x2, x3 represents columns, features. Okay, and one of the column is gender. But how can I take this gender column and substitute in this equation to get the output? I'll just repeat my question. My question is, gender being non-numeric, a categorical column, how can I include a categorical column in a mathematical equation? Is that possible or not? It's impossible. Why? I'll again multiply it. I'll include these categorical values in this equation. 1 into m, 2 into f, whatever might be. So 1 into m, right? Yes. Plus m plus you'll have some other variables. So you'll get a value over here, some x value. What is m plus that value? Will you get a value? No. This is categorical. This is numeric. How can you add a plus 1? Will you get a number or will you get a value? What will be the output? I cannot get anything. If I get an output, then I can say I myself as brilliant, because this is impossible. How can you add a categorical column and a numeric column? So the doubt rises here. How can we include categorical features in a mathematical equation? How do you represent them in a mathematical form? Right? But can you remove it, Akhil? Since it is a mathematical, equation that I'm going to predict, I'm going to bring. I'll do one thing. I'll remove this gender column from the prediction, so that I can include the rest of the columns and I'll proceed. Okay. But do you think gender is not that much, it's not relevant to the use case? Gender is very much, there, it's completely relevant. Cancer does not grow, cancer cells in general, they don't grow similar in both male and female bodies. Completely the tissues that or the cells that are part of cancer, they go in a different manner. So how can you ignore this column? It's impossible. This is very important column, a very important feature. Just being categorical, you cannot drop. Then comes the concept of dummy variables or feature encoding. Then comes the concept of feature encoding or dummy variables. So for this column, I'll come up with the dummy columns. How come? Simple. I'll convert this non-numeric data, categorical data, into numeric data. That is called as dummy variables creation. Is that possible, Akhil? Yes. And under dummy variables creation, we have two types, friends. One is one hot encoding, and the second one is label encoding. One hot encoding and label encoding. For this, I'll take a small, you know, I'll take Excel sheet so that it will be very clear for us. I'll just we'll just understand what is one hot encoding and dummy, yes, label encoding. Then I'll stop. What is the data? Data is nothing but gender. What are the values that I have? The values that I have is male, female, male, female, female, male. These are the six values, six patients. Now, let us understand what is this one hot encoding. Then, next one is label. These are the two different types, right? Under one, dummy variable creation, we have two different types of, there are two different techniques. One is one hot encoding, the other one is label encoding. What is the difference between one hot and label encoding is what we are going to understand. Right. First, we'll talk about one hot encoding. Right. So, right. So this is gender column. Now let us understand how one hot encoding works. One hot encoding initially checks for number of distinct values present in the categorical or non-numeric column. So how many distinct or unique values that we have? There are two different values under gender column. So it creates two columns with respect to one hot encoding. One is gender underscore female, then the next one is gender underscore male. Akhil, are you biased towards female? Why did you write female first? Remove female and write male over here. I don't want to have female first. If that is the question, no friends. I'm not biased. This is what happens. The reason is alphabetically out of all these categories, does M comes first or F comes first? Obviously, alphabetically F comes first. So I'm not biased. Okay. So this is how it creates the columns. Okay. Gender female will be the first column. Gender male will be the second column. Now, let us talk about the values that will be part of these two columns. So if it checks for the original column, the first value is male, right? So this column is talking about gender underscore female. Is it female? Is the value female? No. So since it is not female, it assigns 0. If it is female, it assigns 1. 0, 1, 1, 0. Is it clear? Yes, it's simple. Now the same happens here. Male, yes. Female 0, male 1, female 0, female 0, then finally male. So, as part of one hot encoding, you can observe only two values. What are the two values? Either 0 or 1. Okay, you can observe only two values. One is 0 or the other value will be 1. And how many columns does one hot encoding returns? The number of columns that one hot encoding returns is depending on number of distinct categories present in the non-numeric data, non-numeric column or categorical column. Since I have two, it returns two columns. Now let us go and talk about label encoding. Label encoding, it does not, check for number of categories. Even though if I have 200 or 500, n number of categories, it just returns only one column, friends. In the one column itself, it returns the output. Okay. Then, depending on the alphabetical nature, it assigns the values. Okay. It checks for categories now. What are the different categories I have? Male and female, only these two. Which comes first? Obviously, females comes first. So this will be 0. What is the next category that I have? Male. Male, wherever male I have, that will be 1. Wherever female I have, that will be 0. Understood? So this is how label encoding works. So Akhil, do you mean to say that these two columns are same? No. No, friends. What if I have third category? If I have third category, this will be 2. This will be 2. And can you expect a 2 in one hot encoding? No. One hot encoding, what does it do? It creates one more column, gender underscore O. So this will be 0, 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 0. But here it will be 1. This will be 0, this will be 0. Understood? This is how, one hot encoding and label encoding works. And if you see, non-numeric data that I have, the categorical data that I have is converted to numeric data. And if I have numeric data, I can, simply go and use this numeric data columns in my next phase, model building part. But the question is, when should I use label encoding and when should I use one hot encoding? When should I use one hot encoding? When should I use label encoding? The question comes here. So it's a blind technique that we follow. If you are going to encode a non-numeric column into numeric column, and if it is output of yours, then go and use label encoding. And if you want to encode input values, input columns, then go and perform one hot encoding. Simple. Okay, so for one hot encoding, in order to, if it is an input in the data set, then go and perform one hot encoding. If it is output with respect to your data set, then go and perform label encoding. The reason is why one hot encoding cannot be performed on the output. The main reason is, for any data set in general, you will have only one output. Like I take the same use case. What are we going to predict in this? I am predicting whether a person will have cancer or not. Okay, a patient will have cancer or not is what my use case. Okay, so with respect to my y, I will have cancer or no cancer. Only these two as my values, right? Yes. But if I perform label encoding, I'll get again only a single column. Under one column, I'll get the values converted to numeric. Fine. But on the same output column, if I perform one hot encoding, I'll get two output columns, which is not preferred. Because one hot encoding, it increases number of columns. Whereas in label encoding, the number of columns are fixed, that is 1. With respect to one hot encoding, the values are fixed, 0 and 1. Only 0 and 1 is what you can observe here. But under label encoding, the values depend on number of categories under the original non-numeric or categorical column. They are not fixed. Okay, and one more important point, as we observe when we perform one hot encoding on the original data, you see the number of columns are getting increased, right? So when the number of columns are getting increased, only this is possible with respect to one hot encoding. Okay, so we can also drop the first column. We can drop the first column. Why? Even though if you drop this column, if you don't have this column, by considering these two values, I can get the values of the original column, right? If this is 1 and if this is 0, obviously this should be 0. Why? Because gender underscore male is 1, obviously the original value will be male. But if you say in the second case, gender underscore male is 0, gender underscore O is also 0. Okay, if these both are 0, obviously gender underscore female will be 1. So the original value will be 1, F female. So I can drop this column to reduce my data post working on encoding. So when you are trying to encode with respect to one hot, you can also reduce the data dimension, okay, by dropping the first column. That is possible even though if you don't have the first column, yes, you can understand or you can interpret the original data. But don't try to drop two columns. If you try to drop two columns, it is not possible. Because in this case, if this is 0, what is the original value? Is it 0 or is it male or female? If you try to drop both, you don't know. So even though if you don't have one column, if you drop off the first column, by having the rest of the columns, you can identify the original value. Right. So I'll stop it here. We'll continue with respect to the hands-on. Okay. In tomorrow's class for dummy variables and feature encoding, and it's up to you. Okay. I want so if you have any kind of technical questions, yes. Any questions with respect to the topics that we have discussed today? The feedback link has been provided, so please share your valuable feedback before you leave, and also just hit on the like button if you feel these sessions are really amazing. Share across multiple channels, friends. Some of you are using these sessions in a use of binarization. That's what, see, until unless if you want to build a discrete column using continuous data. If there is a continuous data and if you want to build a discrete column, then yes. And especially if you want to do it into two labels, only two bins, then you have to go for binarization. Chirus, where is the question? Ask him to better post it. No. Okay, when an attribute error will raised, and what are the steps to be taken to resolve it? So, what is the attribute error that you are facing, my friend? That's what I told you. If you have any kind of questions, use that comment section. I'll try to solve it because attribute error comes for many reasons. Attribute error is generally representing the particular column might be, but in some cases, with respect irrespective of the data, also you may get attribute error. So I have to go and look it properly. Yeah, see, if you are off, but if you have any questions, stay back. A roadmap for data science using AI. So the roadmap will be, for data science, start with Python, then SQL, okay, Then go with the statistics concepts. Okay. Then the basic algorithms. That's more than enough. And you can use, one of the LLM, say ChatGPT or Microsoft Copilot, Google's Gemini, whatever it might be. Use one of the LLM, and that will direct you. But this will be the roadmap. Simple. Any other questions? Thank you so much, friends. It was, we had a great session today, and majority of you are also responding well. I would like to wish you guys continue the same till the last. Thank you so much for joining. Yep. Have a great day, friends. Signing off. Bye.